Welcome to this webinar on INCA tools. Yeah, and the title of today is INCA Sensor working together with INCA MPC. People are still joining, but we will start with an introduction, and the most important part of the webinar will start in about 5 minutes. So in the meantime, more people can join. Now, we as IPCOS, we constantly invest in the development of our INCA tools suite. And the latest efforts have been focusing on INCA MPC with the release of, for instance, INCA Architect. We had a webinar a couple of 1 year ago, I think, on INCA Architect. The addition of closed loop ID in discovery, the improvements in aptitude. So that were all releases that came available during the course of this year or last year. Now, in the last year, so this year, then we started to significantly invest in the further development of INCA Sensor, and that resulted in an improved workflow and more integration with the INCA MPC. Because as we're going to discuss today, soft sensors and MPC things are going very often hand in hand in APC solutions. Yeah, so that will be the topic of today. The speaker of today is Leon Ariaans. Yeah, he's going to introduce himself after I finished my introduction. And what is also important, of course, during the webinar, you can raise questions or comments. Therefore, there is a Q&A tab on the application of Zoho Webinar. Or you also see that call out sign with that question mark. Well, there you can raise your questions. I will make notes of all these questions, and at the end of the webinar or the presentation of Leon, I will then raise all your questions. If there are too many, we might only focus on a couple of questions, but anyhow, don't worry. We will send you all the answers via email in case we have to drop a couple of the questions because the list is too long. Yeah. For many, many years, I always gave an introduction on IPCOS. Yeah. And now for, I think, the first webinar, I'm going to show you a couple of different slides. And the first slide, which is different, is not about IPCOS, yeah, but about PA Solutions, Process Automation Solutions, the company that acquired IPCOS in December 2022. It's a company having about 1,600 employees across the world with a focus on chemicals and energy. And Leon and I are from the chemicals and energy division. But there is also a business unit, pharma biotech and food and beverage. So you see, we have about 70 offices around the world. As IPCOS, we had 7 offices. We still have 7 offices, but our presence has now increased to 70, which means I don't say there is always a PA office nearby, because that depends where you are in the world. But at least we are much closer to where our customers are, since we are part of PA Solutions. Yeah, the focus of PA is on optimization, and that's also where Leon and I are coming from that business unit, automation and digitalization. But I will come to that later on. Yeah. Good. PA as such is also part of a bigger organization, and that is the Canadian company ATS, yeah, wherein 7,000 people work, yeah, and it's a company which is highly focused on building machines and also, of course, automation in many industries. So about 80 offices around the world. Focus is definitely China, Asia, Europe, and of course North America, so Canada and the US, with a turnover of 2.6 billion. I think it's Canadian dollars, which is the currency over here. And you see they are active in more areas than PA. So PA is, as I said, food, pharma, and chemicals. But also transportation, consumer products, and energy are one of the key markets of ATS. Good. Okay, so that was the mother and our grandmother. Huh? Now let's go back a little bit to PA and where we belong. So as I said, in PA, you have 3 business units. Chemicals and energy is one. I am from chemicals and energy. And there we offer automation solutions, meaning delivering DCS systems, PLC systems, programming, integration, and so on. Digital solutions, so bringing everything from the automation level to the cloud and everything which is in between, so MES, ERP integration, cybersecurity, and so on. And then you have process optimization, and that's where advanced process control, soft sensing, and PID control resides. Yeah. There is within PA a business unit which is about products, yeah, and under these products umbrella, there you will find INCA tools, INCA MPC, INCA Sensor, Aptitude, and so on. Yeah. Okay. Good. Yeah. So within optimization, because that's close to the heart of what we do and APC, MPC, yeah, this is somewhat what we call or that we promote within the industry as a smart automation, which starts with the plant and its automation level, which then can be provided by PA Solution, our mother company. Yeah, and then bringing the data to, for instance, the cloud. Yeah, if that is allowed, of course. Yeah, and then doing smart things with it, which can be things like modeling, AI, APC modeling, RTO, and that are all possibilities, smart things you can do with your data. Yeah, when you talk about optimization, of course, and based on that, then build a solution based on technology that you use for closed loop control, closed loop optimization, but also for help. So consulting you on things, how you can improve things like for instance, emissions and energy consumption and so on. If you want to have a specific presentation or discussion about that whole portfolio of solutions that we offer, please drop us an email, and we are happy to guide you in that. Yeah. Okay. We are technology independent, which means that we work with most of the brands that are available in the world. Yeah, you see a couple of them over there. But of course, for APC, although we are technology independent, so we also offer solutions based on the most common APC brands that are available on the market. We also have our own solution, which is called INCA under the INCA Tools umbrella. Good. So time to stop the introduction and to hand over the floor to my colleague Leon Ariaans, who is going to introduce himself. So Leon, the floor is yours.
Thank you. Just a moment. There I am.
Okay.
So let me first remove this one. There we go. Okay, so I don't have a video, I don't have a slide to present myself, couldn't bring myself to make one, but I think I know what that is about. I'm Leon Ariaans. I got my PhD from the Eindhoven University way back in 1997. And my professor, my promoter at the time, Ton Baks, he was the managing director of a company in the Dutch town Best. So after my PhD, I joined the Best office there. And when he and 7 other people started a company called IPCOS Technology, actually in 1998, I was one of these 7 other people. So way back in 1998, I started working on what we call INCA MPC these days. Soon thereafter, we started working together with a company called ISMC. We knew several people from that company from the university days already. They had products called Rapid, which is now PID tuner, INCA PID tuner, and Presto, which is INCA Sensor, which is going to be the main topic of today, actually. I left IPCOS and worked in an entirely different, it's not an industry, in a financial institution for a while, but I returned to IPCOS in 2005, picked up working on INCA MPC and other tools in the INCA Suite, and I'm still doing that, heading the team that develops, maintains, and supports INCA MPC. So that's about me. What's the the topic, the content of this webinar going to be, first I'm going to talk about the INCA Suite, focusing on INCA MPC and INCA Sensor. What are the highlights, what are the features of that tool set? I will zoom in a bit on soft sensing in the second part, with a firm eye on INCA Sensor, but the comments I make are going to be more applicable to soft sensing in general. It's not necessarily INCA Sensor on its own. If you have witnessed other webinars I've given, you probably expect a lot of demoing of INCA aptitude, of INCA applications. I'm going to give a demo, but the amount of time awarded to that is going to be much more limited than it normally is. To leave time for the final section, which is looking ahead, and that's about the INCA Suite as a whole. So what are our plans for the future for the INCA Suite? Now, before starting, let me see if I can convince my camera to really work. Well, okay, it worked. Okay, so here we go. The INCA Suite of tools. There's two pillars in our INCA Suite of tools. We call one the offline tools and the other the online tools. The offline tools are the PRD tuning tools. Currently, that's INCA AptiTune, INCA PRD Tuner. I have some news to share about that at the end of this presentation when I talk about the suite again. But this presentation will mainly be about what we call the online tools. The online tools are first and foremost INCA MPC, our model predictive controller. But INCA Sensor is also considered part of the online tools, and actually the two of them, INCA MPC and INCA Sensor, they work together rather nicely, and that's what this webinar is also trying to convey. I think my camera dropped out again. Well, you will have to do without my image then. Okay, so what is INCA MPC? INCA MPC is a state-of-the-art MPC technology, we believe. If you look at the features of INCA MPC, I think one of the more important features these days is not so much a technical one, but a commercial one. We have a flexible licensing mechanism, or we have a flexible license offering, I should say. We offer term and perpetual licenses. Perpetual licenses combined with software maintenance and support, SMS packages. So whatever suits your needs best, we probably can accommodate you. We have a lot of emphasis on backwards compatibility in our tools. When we introduce new features, we try to do that in a backwards compatible way, such that you can opt into them. But if you don't do anything, well, things work as they worked before. In cases where it's not really possible to make them opt in, we introduce modes. So our INCA MPC currently has several modes, where a mode introduces at least one feature that's different from what we had, but it does so in a backwards compatible way. There are features that we introduced 25 years ago that we still support, although I will have some updates on how we intend to move forward in that area. But backwards compatibility is something that's very important to us. We don't want you to install a new version of the suite and then your old configuration doesn't work anymore. INCA MPC is used in very small to very large applications. The smallest I'm aware of really has 1 MV combined with a couple of disturbance variables. The largest one I'm aware of has a bit over 100 MVs in total. So that's a wide range of sizes. It should fit the needs you have. INCA MPC works with any DCS on the market. Some integration work is required such that the switching logic, if you switch an MPC on the DCS, it should have matching behavior. That requires integration work on the DCS. We actually also provide services to help you with that bit. So we work with any DCS on the market, and we also have, we call these things multi-mappings that take the conversion of, let's say, the status of a PID loop, handle that for you such that INCA MPC understands whether it's in the state that it needs to be, whether it can be used or not. So works with any DCS on the market. We provide a browser-based interface for engineers and operators. For engineers, they need to use that. If you create a new controller, you do that in that browser-based interface. If you're going to introduce roles for people, operator roles, engineering roles, but you can have them also more refined, saying a role that is an operator for unit such and such, and another operator role for another unit. You can introduce those roles, assign access rights to those roles. That happens through that browser-based interface. Operators can also use that browser-based interface, and there's companies doing that where the browser is the main user interface for INCA MPC. Other customers prefer to have screens on the DCS that allow the operators to operate INCA MPC, and actually you don't have to choose, one doesn't exclude the other. The main advantage of using the browser-based interface as the operator interface is you don't have to do anything additionally. It comes with the package, and if you make any changes to the configuration, if you add an MV or a CV, the interface follows along automatically. No further work is needed there. We include support for automated step testing. We do modeling based on data that we collect from the plant, from the unit from MPC. During that, or while collecting that data, it's important that steps are applied to the process so that we can see how it responds to those steps. Those steps can be applied manually, but you can also ask INCA MPC to do that for you. What it takes is an initial model of the plant where you need to have a rough order, a rough idea of what the gains are, of what the speed of the responses, the time constants are. So, but if you have a rough model like that, you can ask INCA MPC to do the application of steps for you. So it will generate patterns of steps that you can use in your identification. And it will try to keep your process between the process limits based on the model that you have. You have a bit of a chicken and egg problem here. You're doing the step testing so that you can estimate a model, but you need a model so that the step testing can stay within constraints. But we're not optimizing the process, and we're not pushing it to its limits. We're only trying to keep it between constraints. So that's why a simple seed model is typically good enough. And also, when you are doing maintenance to an MPC, you already have what's probably a pretty accurate model in place already. So then switching to stepping mode to collect further data to improve your model after a while, that's also something where automatic stepping can help you with. So automated stepping, that's or actually manual stepping, that's leading to the system identification phase where you identify a model, where you try and find a model that describes how the process behaves, how it responds to the changes that happen at the independent inputs, the independent variables of the MPC. So we have a powerful system identification suite there, INCA Discovery. I will be showing that later on. And in that system identification, we allow to reflect in the identification phase already that you have certain a priori knowledge of the process. If you know that it has a certain dead time, you don't have to recover that from identification. You can tell identification that it needs to come up with this. It's not a post-processing of the model you can apply there, but it's actually enforced during identification already. Same with the gains of the process. If you know what the gain is, you can enforce that. The identification will take care of that. And going beyond that, INCA Discovery was actually the first in the industry that allowed you to specify that there are certain mass balance constraints or gain ratio constraints that should be present between certain curves. If you have that knowledge, you can impose them on the system identification, and the system identification will reflect that information during the identification already. It's not a post-processing that you do. Also, maybe not exactly system identification, but integrated in the same package. It's important to make an analysis whether your independent variables have their own effect on the CV or on the dependent variables, or whether they are what's called collinear in statistical terms. If they are collinear, it means you can't control a CV, or you can't control two CVs independently. If you move one in a given direction, you already will know what another one will do, because it follows that exactly. In statistical terms, that's collinearity. If it's exactly collinear, that's not a problem, because then the controller doesn't have freedom to optimize that. But if it's almost collinear, you need to tell the controller what your intention is. Do you want the controller to control them independently? Then you probably have to pull them apart a bit, because otherwise it's going to make very big moves. Or if you say, well, don't bother trying to control them independently, it's going to take too big moves on the input side anyway. Then you have to make them exactly collinear. And the analysis tool and the way to fix the situation, that's also integrated in INCA Discovery. Now, when we move from identification to the actual optimization, where INCA MPC does its best to control the process, then you will find the features that you expect from a modern MPC. It has prioritized constraints. Safety constraints are more important than quality, than economic constraints. You don't want to get anybody killed if that gives you a euro extra. So prioritized constraints are in there, but you also need to tell the MPC what it means to be optimal. And in the first versions 25 years ago, that was ideal value based. You needed, if you knew this is where you need to be, then you specified those ideal values. Alternatively, you can now also specify cost optimization, where you assign a cost to every manipulated variable, either positive or negative. And then the MPC tries to minimize the cost. And actually, one doesn't exclude the other. You can combine the two. Although it's also often the case that when you have optimized your cost, you have no freedom left to optimize the ideals. INCA MPC supports both, whatever suits your needs. Then there's three qualities of control variables that start with int. Let me very briefly go over them. Integrating CVs. Other packages call them ramps. Normally, when you make a step change, when you apply a change to the independent variables, there's going to be a transition period, and then eventually your control variables settle on a new fixed value. For an integrating CV, it doesn't settle on a fixed value, it settles on a fixed rate of change. If you have a flow that goes into a vessel and another one coming out, if the two balance each other, the level is going to stay constant. But if you increase the inflow, you will see that the level in that vessel is going to rise with a constant speed. That's an integrating CV, and it takes special configuration, special tuning to handle that case. INCA MPC supports that. Actually has two flavors, one where you try to be balanced all the time, and one where you say, in terms of this vessel example that I gave, as long as you don't overflow or underflow the vessel, everything's fine. And this is not limited to vessels. Pressures in a reactor are also often integrating. Then there's a feature called intermediate variables. I'll very briefly try to explain what this is about, but there's blocks explaining this in more detail. The defining aspect of an intermediate variables is, first, it's something that responds to the MVs and DVs, so it reacts to what the controller does. But having a measurement of it, it also allows you to make a better prediction of CVs. So it basically improves the predictions of your CVs For example, if you have a reactor followed by a distillation column, then if the composition of the feed in the reactor changes, that will have an effect on the pressure in the distillation column further on. It takes quite a while to see that, but an early indication of that happening is that the pressure drop over the reactor changes, and you can use that measurement to improve your predictions. There's even more tricks you can apply if the intermediate variable is the PV of a PID loop. Have a look at the block. Intermittent variables, that's the last int that touches upon sensors. I'll return to that after I talked about sensor. Now let's move to INCA Sensor. INCA Sensor has used powerful AI-based models, and that goes all the way back to 1995. The roots of the INCA Sensor models, they go way back, so well before AI became the hot topic it currently is. So we have been employing that for almost 30 years now. We share the licensing mechanism, the licensing offerings that INCA MPC has to offer. So here too, you can choose between a term and a perpetual offering. And here too, we put great emphasis on being backwards compatible while still introducing new features, but not killing your existing configurations. In INCA Sensor, we put emphasis on ease of use, ease of modeling. You do not need a data science degree to use the modeling in INCA Sensor. We want this to be easy, so that also helps with maintaining your models. We also do not require special hardware to do the learning, as we would call it these days, the machine learning, or the running the models online. I will be showing you the modeling of one sensor in a minute. That will be on my own laptop. You don't need a cloud cluster to provide you with the compute power that you need there. Modest hardware requirements are more than sufficient. We share the browser-based interface with engineers and operators. And well, when I explain the soft sensing concept, I will be talking about analyzers and lab samples. You can enter the values of these lab samples through that view, through that browser-based interface, or through the LIMS systems that you probably also have in place already. And you can get real-time data via OPC. You need those for INCA Sensor. It's integrated with INCA MPCs. It shares the same workflow doing it. And that means, for example, that there's easy configuration of INCA Sensor via INCA Architect. Now, INCA MPC is proven technology. I showed you a list of companies already where we use it. These are the areas where we use it. Now, let me talk about why soft sensing. What are the benefits of soft sensing? Soft sensing comes into play when there's a quantity that you want to measure, but that you do not have direct access to. For example, the composition in a distillation column at the top of a distillation column, that's typically not something you can measure directly. Or the, let's say, the melt flow index of a polymer, that's also not something you have a measurement for. You can take a sample, take that to the lab, and then you will get that value. So in that sense, you have a measurement. But that's labor intensive, first of all, and it's also slow. At getting one measurement is slow, you will get it with a significant delay. Now, an alternative there, or an additional thing, you probably need lab samples when you have analyzers as well, is to use an online analyzer. Online analyzers, they automate the process of taking a sample, doing the analysis, generating a measurement. But they are expensive to buy, and they are also expensive to maintain. You have to calibrate them, clean them, so that's expensive. And also, there's not an analyzer available for every measurement for which you might have a lab measurement. But they're already faster than lab samples, but they may not be fast enough for your purposes already. That's where soft sensing comes into the picture. Soft sensing is where you estimate a quantity based on measurements that you have readily available. Think temperatures, think pressures, think flows. In combination with a model that you have that say, if my available measurements are this, given that I'm producing this product in this reactor, etc., I have a pretty good idea of what the quantity is. So the model and the measurements give you an estimate for the quantity. But that's also important in a lab, in a soft sensor, you typically have a mechanism in place where you correct if the soft sensor is drifting away. So you get the speed up while still maintaining the accuracy that lab samples would provide you. So that brings us to the benefits of soft sensing. They are cheap to run, they are easy to develop, they are fast, and they can be accurate enough. They are typically accurate enough for use in closed loop applications, so that when you have the combination of an MPC and a soft sensor, the two of them can make sure that your product is on spec already before the lab sample is available. You probably still need the lab sample to prove to your customer that you are on spec, that you meet the requirements, but you don't have to wait for the lab sample to take corrective action. And so that's where the value of soft sensing is, apart from the other advantages that I mentioned. You are faster making corrections. In the context of this presentation, I'm saying that MPC is doing the correction, but you can also use a soft sensor and have an operator make the corrections. There too, a soft sensor is valuable. I mentioned intermittent CVs. What are intermittent CVs? They are variables in a controller where you don't have a measurement all the time. You can say that that's a poor man's version of a soft sensor, but soft sensing is more powerful. A soft sensor allows you to say, I have a lab sample and it was taken, well, a few minutes ago, or can be even longer, and then you can still apply that update, whereas if you have an intermittent CV, you get a value now. So the timing of updates, that's one thing that's different. The model types that you can use for soft sensing, they are not limited by the requirements that your MPC has for the model. And well, not mentioned on this slide, but actually the bias mechanism, the updating of the bias, that's also a powerful feature. Now, before I move to the demo, I've collected a couple of links here where there's further reading. If intermediate variables were explained a bit too quickly, there's two blogs on it on the INCA Tools site. I'm going to show INCA Architect very briefly, but I did a full-blown webinar on it. There's a YouTube link to it. You can't tell from what I'm showing you now, but the full links will actually be in the handouts that we provide after the webinar. Okay, so let's move to the demo. INCA Discovery. You may know it from INCA MPC. As Christian already mentioned, we integrated the soft sensor modeling functionality into INCA Discovery. And one of the places where you can see that in action is if you look at the model plots. There we have it. Here you don't see it yet. But when I zoom in further, you actually see that this is not a signal sampled every 30 seconds, but you see that it was sampled at, well, where the bullets are. That's where a sample was taken, and they are not equidistant. So support for that, that's part of the addition that is required. The other thing is, well, normally when you make MPC models, you make cases. Here we have sensor cases, and sensor cases give you the modeling capability that the previous INCA Sensor offline provided you with, where you have both linear and nonlinear static models. Now, if I run the identification now, you can see how long it takes in action for the model fitting to appear. Well, there it is. There's not a huge supercomputer doing this. This is my laptop. So this is as long as it takes to do the modeling. Actually using the models online is faster than this. So you really don't need a high-blown computer hardware for this. When you compare this to the old INCA sensor, we now provide you with model plots where you see what the model does. And that's actually more interesting when I make a nonlinear model. And hang on, when I show you the nonlinear model. Here you get to see how the output is in the y-axis of these 5 plots, how the output behaves when the input moves along the x-axis. And this being a nonlinear model, what happens when you make that move also depends on what the other inputs do. And that's what these up-down things are for. They allow you to move with your independent variable. And then all the other plots show what happens when that independent variable is at that position. So that's an addition that we made where you can see what the model does. Another addition that I want to show you here is we can show statistics here, and these are actually more interesting for the linear model. We show you statistics here where you can see what is the contribution of the different inputs that we have, the different independent variables to the output. So in this case, that's a linear model. Here you see the coefficients and the offset. There's also components, think latent variables. I won't go into too much detail here, but you probably know them from the old INCA sensor. Here you see what the contribution to the output of the various components is. So this also allows you to judge, do I have enough components? And here you can see what the contribution to every latent variable of each and every input is. That also is an indication, is an input, is an independent variable adding to the modeling, or should I just drop it? Then final thing I want to show you here is the predictions of the model. The green line here, that's the lab samples that we took. The red line is what the model identification fitted to it. And that's how the inputs explain what the output does. There's another line here that I can enable here. That's the blue line. And the blue line is what INCA Sensor would have predicted online if you had applied it. The red line doesn't apply any, well, bias updating. The blue line shows you what happens when you have the bias updating in place. And that actually explains, hang on, and it's sensor case, what these parameters are about. You may recognize tau bias, forget bias. They tweak how the model update, how the update of the model takes place online. You can play with them here and see in the prediction how that would have affected the online predictions. So that's the modeling part. Now you export the model from here, and then you take that into INCA Architect. Is that letting me down now? No, it's not. Okay, so I'm not going to talk about all the parameters that we hear, but I want to highlight one feature. That's the triggering mechanism. We're very flexible in how you can say that you have an update available, where an update is either a lab sample that becomes available or an analyzer that completes its measurement. There's 3 ways of doing that: providing an explicit signal that you're ready, see that the timestamp changed, or see that the value changed. Yeah, there's other stuff here, but let's skip that for another time, so that I still have time to show you what the viewer looks like. Just a moment. There we go. So here you see in a simulation example where there's mostly noise, what it looks like if you have an analyzer. Now this demo example, that's running way faster than is realistic. It's running every 5 seconds, and you get an analyzer update every 50 seconds. But if I zoom in a bit here, you see better that the blue line, that's what the sensor produced. We have noisy input, so that's what you get to see here as well. The red lines are the analyzer updates, and you can also actually analyzer updates. They come rather equally spaced at a rather high frequency. But you can also add a new lab sample here. If you specify that here, you can specify when was it exactly that this happened, that I had this this timestamp. What was the value? You can specify capture value here. It lets you see what the model did to see if you are if it's a sensible value that you had in mind. So this is the operator screen that you get to see here. If you want to see what it looks like to upload a new value, a new configuration, I'm going to refer you to the other webinars that I did. So let that be the demo part. Let's move on to looking forward with the INCA Suite. So let's skip ahead about slides for the demo. So
Yes.
looking ahead. As I said, the suite has two pillars, the online suite pillar and the offline suite. Well, the first new thing that I want to stress, and that's something we announced also in earlier releases that we did. We will be stopping to include the old classic configurations, as we currently call them, and a modern configuration, that's one that's using the viewer that keeps running when you log off. If you see good old task manager, the data server, the scheduler, if you've made configurations like these, you will recognize what I'm talking about. We will still have these in the install set this January, but that will be the last one that we include that on. We started the alternative 10 years ago. So after 10 years, we say we really think there's a better way of doing this. So scheduler and task manager will not be on in the install set as of April next year. Doesn't mean that the existing ones stop working, but we no longer sell new licenses for them. You may extend the existing one, but not new ones. We won't be supporting it anymore. Another thing is we have a free version of Aptitude, and that's actually not an upcoming change. That version is on the website ready to be downloaded as we speak. Mm-hmm. That's a restricted version of Aptitude. It doesn't optimize the tuning. It applies Ziegler-Nichols lambda tau tuning rules, but that can still give you a head start. If you need more functionality than that, there's actually additional versions of Aptitude that we have now, where one is the single input, single output Aptitude, which is also a reduced version of what used to be the one and only Aptitude. There's the Aptitude that we currently have, that's the premium version, and then there's an enterprise version with additional bells and whistles. If you want to see the full feature set, have a look at the website. We do intend to streamline our PID tuning offering, so the single input, single output Aptitude is also going to replace INCA PID tuner as of April. So we will be simplifying our PID tuning offering. Those are things I can promise that have happened or are happening. We're also looking into functionality in the INCA Suite that I've called here opening up, and there's actually a couple of things that are under this banner. We want to modernize the way people log on to the viewer so that you can more easily provide different ways of authenticating people. There's modern ways of doing that these days that were not available when we started implementing this 10 years ago. So that's one thing that we have in mind when we say opening up. Another thing is that we're looking into possibilities to publish the data of the online controller or sensor. And when I say publish, I mean make it available in a way that's easy to ingress in whatever analysis tool you want to use to do performance monitoring, performance analysis. We don't intend to come up with a new trend miner or a new seed, but we do want to make it easy to get data into tools like that. That's another thing under the banner of opening up. And the final thing I want to mention here, I already said that the roots of Sensor go back, well, almost 30 years by now. We did AI implementations way back then already. But that doesn't mean that the field of artificial intelligence, of machine learning, hasn't improved since then. So we're also investigating, are there ways to enhance the soft sensing modeling and the soft sensing execution part, while still meeting the constraints that we have, or the goals that we have, to make the modeling easy to use and the soft sensor robust to run without putting a big computational load on your implementation.
Good.
Yeah.
That's it.
That's it.
Thank you very much, Leon. So time for questions. So as I already told you before, there is a Q&A tab on the platform where you can write down your questions. They will pop up here immediately, and then I will raise a question to Leon. Or there is that call out sign with that question mark, and that's also there you are again. And that's oh wait, I will
for as long as it takes.
add myself also to the okay. So good. A couple of questions. So while you were talking, Leon, a couple of questions already came in, but yes, please, if you still have more, don't hesitate to raise them through this Q&A bar. Yeah. First question that came in is, can one sensor use both lab samples and analyzer updates?
Yeah.
I don't know if I understand the question completely. Does it perhaps it mean I read this like analyzer data coming in on a regular basis, and on top of that you want to add lab samples? Is that how I should read this? I don't know, but that's how we read this. Let's say.
Let's say that makes sense to me.
Okay.
That is, if you currently want to do that, then what we do is we apply two sensors. So one that handles the updates from the analyzer, and another one on top of that updates that sensor based on the lab sample values that we get. It's actually a feature that is going to be made available in one of the upcoming releases, to put that in one sensor. It's not going to give you a different estimate, but it's going to streamline the user interface in the viewer. So it's possible to do that already now. It's going to be simpler in one of the upcoming releases.
Okay, good. This is a nice one. Has been around for already many years, but now it starts to pop up more and more. OPC UA.
Yep. We released OPC support for OPC UA in the previous release. As you mentioned, OPC UA, I don't know exactly when it was defined, but it must be around 2005. But we haven't seen it much in the years since then, up to maybe couple months, half a year. People have been starting to ask for OPC UA, and we added support for OPC UA in the INCA Suite previous release. That applies to MPC, and that applies to INCA Sensor. We haven't made it available yet in INCA Acquire. That's a tool that we provide for data acquisition purposes. It's not a full-blown industrial grade data acquisition tool, but for modeling, it's definitely more than adequate. We are looking into our options of adding it there. We aim to have it there, but we're still looking what the options are there. So OPC UA for Sensor MPC available already. For Acquire, we're doing our best.
Okay, good. One more here. Can I still use an old configuration?
That's probably after it's no longer on the
okay.
on, at least that's what I make of it.
Yeah, well, indeed, yeah. So that would be probably. But...
Yes, you can. We do not force you to upgrade. We do recommend that you upgrade. The process of maintaining a controller, bringing one online, and that's much easier with the new tooling than it ever was in the old one. So we really think the new tooling is an improvement over the old one. Having said that, if it's running, it doesn't stop running when we no longer put it on the install set. And it's not that if you have a perpetual license for it or a term license for that matter, that we say, well, we don't allow you to use that anymore, but we won't support it anymore. If you find an issue with it, which would be strange that you find that right after we stop supporting it and you haven't found it in all the years before. There have been very few issues mentioned in the last few years. If you find one, we're not going to fix it. If it works for you, you can keep running with it. We don't force you to upgrade, but we do recommend to upgrade.
Yeah, and the only thing that you need to do to have access to all the new bells and whistles and features, and even the new tools which are added, yeah, is just pay SMS. You don't have to buy extra licenses or so. So you just buy SMS, software maintenance and support, and then you will get automatically things like architect, closed loops, sensor integrated in discovery, and so on. Yeah, so which is important. And that, of course, brings me directly to the next question for somebody who probably already made up his or her mind. Let's move to the new environment. Can architect read an old configuration and do the upgrade?
No, it's not quite that streamlined, but it's also not that you have to start from scratch. The conversion of an MPC, that's more involved than a conversion of a sensor, and the support, the tooling for that is also most well advanced. I'm not sure if that's the right word, but we provide a tool that has been in the install set for quite some time already. That's called Convert ITP. I will add the location of the tool on the install set in the notes that we distribute. So what that does is it takes an old task manager program. That's why it's called ITP, and that's the extension of those programs. It analyzes what happens there, and it gives you an IMPC. That's a modern MPC configuration. That's depending on how much customization you did by means of calyx. If you didn't have any calyx at all, that will be done. Then your conversion is done. What it doesn't convert is the old calyx to the new calyx. So you will have to redo any user calyx that you did. Shouldn't be that difficult because the new user calyx are much more powerful than the old ones. But you have to do that part manually. That's MPC. For soft sensing, well, the sensor configuration consists of two parts, the old model and the tuning parameters there. The list of tuning parameters, that's not that long. You will have to manually transfer them from the old configuration to the new one. The models that are in the old sensor, they need to be converted to the form of models that the new sensor uses, but there's a tool for that, where the old model goes in and the new model comes out. You import that into INCA Architect, then you have the framework of your sensor configuration there. You have to add the parameters from the old configuration, specify which tags to read and write in the OPC server, and that's it. In all, it shouldn't take more than an hour for one sensor to convert it.
Okay, yeah. So, some applications migrate automatically, and for others, you have a little bit of work to do, but it's definitely not a huge amount. So,
That's right.
Okay, good, yeah. Perhaps the last one, because it's 5 minutes to 6 here, is can sensor use dynamic models?
Yes, it can. It has been able to do that for a long time already. You don't see, because I think the question is triggered by me saying that we had static, linear, and nonlinear models in discovery. So what about dynamic ones? It can handle linear dynamic models, but you can just use the models that INCA Discovery estimates for MPC there. So if you can estimate a dynamic model in INCA Discovery, then you can use that as is in Sensor. That's the technical part. What INCA Discovery is not doing, it's not interpolating between the lab samples or anything. So if this is about I have a lab sample, I have a lab sample at irregular intervals, but it's typically half an hour or longer that I have one, and I'm focusing on generating lots of lab samples. Now, can I have a model where dynamics are faster than that? Well, Discovery won't estimate them for you, but you can add dynamics to the models. That's actually one of these taus that are there online. You can interpret them in different ways. But one of the ways of interpreting that tau is that you say, this is the dynamics of my model, and you can specify that there. Then you basically estimate a static model and add the dynamics afterwards. So you, depending on what your use case really is, there's different ways, but it can use dynamic models.
Okay, good. Okay, let's close the webinar. So first of all, thank you everybody who attended to participate. Much appreciated. We will provide you with a copy of the slides in PDF format via email, so that you can distribute it to your colleagues, or you can review it later on. Also, a recording will be made available in the next couple of days through our YouTube channel, and also there you will get a link to that YouTube movie, so that you can also review or have a second look again at the webinar, or distribute it to your colleagues. If you have any questions, please contact us. You will find all the contact information on the INCA Tools or the ipcos.com website. Perhaps as a last announcement, there will be an PA Solutions IPCOS webinar on November 5th on hydrogen. That will be in German, I understood, but a couple of weeks later there will be a same version of that hydrogen webinar, but then in English, which will be given by my colleague Michiel Huizer, if I'm correct. Yeah. So for now, sorry. Many thanks for participating, attending the webinar. Much appreciated. Have a nice evening or have a nice day, depending on where you are in the world, and talk to you soon. Okay. Bye bye.